Hello PLP geometry and welcome to Unit 5, Number 5, covering midpoints and ratio of segments. So this is still in our Unit 5, which we talked about parallelograms to start, but now we're much more focused on the coordinate plane, which is a huge state test idea because it really combines geometry and algebra, because algebra is done on the coordinate plane. Okay, and again, this is number 5, and in number 5 we're talking about midpoints, which we have some prior knowledge of, and then also this special skill of finding a ratio of segments, which the state thinks is important. So we will talk about this. Okay, so let's talk about midpoints for a second. So we know in general that a midpoint is the middle point of a segment, right? It bisects a segment, it splits a segment into two congruent parts. So on a coordinate plane, how are we going to find the midpoint? So this is midpoint on a coordinate plane. Coordinate plane. Okay, so let's say that we have a point A, and because it's our first point, we're going to label its coordinates x1, y1. And let's draw a segment here, and let's call that point B, and let's give its coordinates x2, y2, because it's the second point, right? We should know that the midpoint is right here in the middle. Again, it splits the segment into two congruent segments. This is the midpoint. I'll call it M. Now, there is a formula to find the midpoint. So capital N stands for midpoint. So to find the midpoint, I'm going to make big parentheses because these are fractions. What we're going to do is we're going to take our two x values. We're going to add them. So x1 plus x2 and divide it by 2. That'll give you the x coordinate of the midpoint. We'll do the same thing with the y values. We'll take y1, add it to y2, and divide by 2. And this is the formula we will use to find the midpoint of a segment on the coordinate plane. Now, if you think about what these fractions mean, if you take two numbers, add them, and divide by 2, you're just finding their average. So when you find the midpoint, you're just finding the average of the x's and the average of the y's. So keep that in mind. Okay? So based off this, I have 3 problems. They're going to increase in difficulty, as math usually does. Okay? So example number 1. So we're just going to find the midpoint. Find the midpoint. Find midpoint between, and the points are going to be 5, 7, and 3, negative 10. Okay, so this is just a simple formula question, right? So again, the midpoint formula is x1 plus x2 divided by 2. y1 plus y2 divided by 2. You will not be given this, so you got to make sure you memorize this, right? Add the x's divided by 2, add the y's divided by 2. So the easiest way to do this is just label your coordinates. So the first one, just put an x1 and a y1 underneath it. The second one, put an x2 and a y2 underneath it. And now we're just going to fill in the numbers where they go. So our x1 is 5, so we're going to do 5 plus your x2 is 3. Divide by 2. Do the same with your y's. y1 is 7 plus y2 is negative 10. Divide by 2. And now we simplify the tops. So 5 plus 3 is 8. So that's 8 divided by 2. 7 plus negative 10 is really 7 minus 10. So you subtract them, and because the 10 is bigger, you're going to stay negative. So negative 3 over 2. And now we just simplify. So 8 divided by 2 is 4. Now, negative 3 divided by 2 does not simplify. It is already simplified. So that is a fraction answer. Or if you want the decimal answer, because it does end nicely, it could be 4, negative 1.5. And that is just simply using the midpoint formula. Now, you can always use Desmos to check. So again, I'm a big proponent of Desmos. I want to keep showing you how to use it. Okay, so let's go there right now. Okay? So if we go to Desmos, remember to zoom out 1, so you're counted by 1s. So again, you could type in, and I'm going to show you a little trick here. So there's a command called polygon. This command will connect the points that you put inside the parentheses. So the parentheses here are for the command polygon. You have to give each set of coordinates its own parentheses. So notice I open a new parenthesis. So 5, 7, close it. Okay. So if you see it showed up, it's just a little speck. They don't give it a big dot. And then comma, and the next one is 3, -10. And there is my segment. So then in the next box, if I put in my answer, which was 4, and I'll do -3/2. Notice they put the point right there. And again, you can see that you're on that segment and looks like you're in the middle. So it's a good way to check. Okay? All right. That was the first one. Again, plug and chug, in my opinion, not that difficult. All right, example 2. Okay, so now we are going to be given the midpoint. So your midpoint, M, is going to be -3, 2. Your end point of segment AB, A, is at -5, 8. We want to find the other endpoint B. Okay, so I'm going to teach this to you all Desmos and graphing. You can do this algebraically, and if you actually ask Delta Math for help, it's going to do it algebraically. So be aware of that, right? But we're going to use Desmos, and it becomes a big slope question. And let's remember that slope is rise over run. So slope is going to be a big help for us the rest of these notes. Okay. So what I'm going to do here, right, is I'm going to kind of work on Desmos, and I'll kind of graph it separately, what you should put in your notes, okay, because I want an accurate graph for this. And again, I hope that you would just use Desmos to do these problems, okay? All right, so I'm going to go to Desmos. Okay. So in Desmos, okay, we're going to put these 2 points, and I'm not going to connect them. I'm okay. So I'm going to put the midpoint, so -3, 2, and I'm going to label it as M because it's important to know which one's the midpoint. And the next box, separately, I'll put -5, 8. You got to do them separately so you can label them. Okay. So again, in my notes, and again, I'll do it right here. Sorry, it's going to be on top of this graph. But I would draw a little graph, right? And I would go -3, 2, and put M. And I'd go -5, 8, 3, 4, 5, 6, 7, 8, and I'd put A. Okay. So this is what my notes looks like. This is what Desmos. So hopefully you understand that A, M, and B are going to be collinear on the same line because they make a segment, right? With M being right smack dab in the middle. So I know that if A is up here, I'll use dark blue. If A is up here and M is here, I know that B has to be somewhere down here, right, to connect that segment. So again, that's our job. To do this, we're going to use slope. So think about this, right? If we know that A and M, that distance, is the same as M to B, then the slope should be the same. So let's count the slope from A to M. So we go down 1, 2, 3, 4, 5, 6, and right 1, 2. So on my picture, I would go down 6 and right 2. So to get to B, I'm going to do the same thing. I'm going to go down 6 and right 2. 1, 2, 3, 4, 5, 6, 1, 2. And this should be where my point is. Right here. So if I go down 6 and right 2, I get here. That is where B is going to be. And it's just our job to identify those coordinates. So to identify those coordinates, we count from the origin. We go left 1, that's -1, and down 4, that's -4. The coordinates of B are left 1, -1, down 4, -4. If I type that into Desmos, -1, -4, and I label that as B, you can see that it landed on top of my marker mark, and you can kind of see that a segment go right between them with M being right in the middle. So again, this finding the other endpoint is just a simple slope problem. Okay, so hopefully that was understandable for you. Okay, Last question. Again, we're stepping it up, right? So this is your third example. So this is example 3. Example 3, Mr. Chappell, not example 2. We already did example 2. I don't want to do it again. Example 3. Okay, this one says we have a segment from -7, 9 to 3, -1. I want to find the point on the segment, that makes a ratio of 2 to 3. You're like, oh my goodness, what the heck does that mean? Ratios, what do we get ourselves into? So again, this is going to be done on Desmos, and again, it's going to involve slope. Okay, so let's go to Desmos and graph this. For this one, I am going to connect them. Okay, and again, I'll do it somewhat on Desmos. Again, there's going to be directions to give you too, so I'll try to find some nice white space to write in. Okay, all right. So if we go to Desmos, okay. So the first point was -7, 9. Oh, so sorry. Let's do the polygon command. So polygon. Okay, parentheses. -7, 9, comma, parentheses, 3, -1. Okay, so there's my segment. Okay, so again, on my notes, I would do the exact same thing, right? I'm gonna do it right up here because I can. So I would find the space. So I would go -7, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's -7, 9. There's, and I'm going to call that A because it's my starting point. That's important. And then 3, -1. And we'll call this B because that's my ending point. So here is your segment AB. And again, I want to find a point on this segment that breaks the segment in a ratio of 2 to 3. That means that when I find this point, and if I compare the distance on either side, again, ratios are hard to explain, but the one side has to look like 2, and the other one has to look like 3. So almost if you think of it as like breaking this into fifths, right, because 2 plus 3 is 5, 2 of those fifths have to be from A to this point, and then 3 of those fifths from B to that point. So this point looks like the middle. So if I just slide a little bit this way, so here, this looks like it could be the 2/5 point, maybe a little bit more close. But this would be a length of 2, and that would be a length of 3. Okay, again, it might need to be, let me just erase that. It might need to be a little bit more up. Okay, so like here. Okay, just an estimate. So how are we going to find that point? Well, we're going to use slope. So again, I'm going to do my directions right over here in the white space. So step 1. Okay, we need to count the slope. So count slope. And we're going to do it from A to B. And in parentheses, no simplify. We're not going to simplify this slope. Typically, we simplify slopes. Here, we're not. So to get from A to B, again, I'm going to use this picture, and then we're going down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and right 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're going down. Oh, yeah, sorry, I went too far. We're going down 10, and we're going right 10. So we are finding a slope which was down 10 and right 10. So that's our slope. Okay? Okay. Step 2. So that's what I do. Step 2. I'll do it in purple. We are going to take the slope, the pieces, and we're going to multiply it by a ratio. So multiply your rise and your run by. And this ratio by ratio, and this ratio is going to be the first number over the sum. So I got to move this. 1 second. There we go. The first number divided by the sum. So in our problem, the first number is 2, and the sum of 2 and 3 is 5. We're going to take our rise and run and multiply them by 2/5. So the rise, -10. The run, +10. Multiply each of them by 2/5. Our new rise and run, and again, you just type the top in a calculator. So that's -20 divided by 5. The bottom is +20 divided by 5. -20 divided by 5 is -4. +20 divided by 5 is +4. Here is going to be the rise and run we must use to get to our new point. This is the rise and run. Now, these are nice numbers, so I could just count. But sometimes they're not nice numbers. So, step 3. I'm going to do it in orange. We need to add the rise, I'm going to say the new rise run to, I'm going to say A's, because that's our first point, A's coordinates. Why did I put that in parentheses? I don't know, because it said coordinates maybe. Okay? All right. So what we're going to do here is we're going to take A's coordinates. And A's coordinates were, again, -7, I'm going to leave a space, and +9. Now, we have to be sure we know that this -4, the rise, goes to the y. So to the y, we're going to subtract 4. And we have to know that this +4, the run, is to the x, and we're going to add 4. And when we do this, -7 plus 4 is -3. 9 minus 4 is 5. And this is going to be the point on that segment that splits this segment into a ratio of 2:3. So again, I would graph that on my piece of paper with -3, 1, 2, 3, 4, 5. Again, I did pretty good, right? So again, there's that point we needed to split it. I'm going to make this writing go away and show you it on Desmos real fast too. So again, hopefully you got this written down. If not, pause real fast. Okay, it's going away. And now again, I'm going to, in here, -3, 5. And again, if you look at it, it looks a little bit offset from the middle, closer to this first point. And again, I would say this could be a ratio of 2:3. Not an easy problem, but a good problem. Okay, and again, the state test loves it, so try to remember how to do it. All right, good luck on this practice. Let me know if you have any questions.